You're welcome to Practical 3, AutoCAD Made Easy Volume 2 Practicals, brought to you by Computer Made Easy. I'm still your instructor, Engineer Adebisi A.T. Grab a seat, launch your AutoCAD, and let's begin. So this Practical 3 will be dealing with curve of intersection of two cylinders. And the drawing we'll be practicing is on page 13 of the main pages. Now, how do we draw curves of two cylinder, intersection curve of two cylinder? First, we're going to ensure we draw the front elevation and the plan for the two cylinders, the front elevation and the plan, which is what I'm going to do right now. I'll be beginning with the front elevation. Now you can see my drawing is isometric mode, which I don't want. I want it to be in. Okay, fine. My drawing is back in orthographic mode. So I want to draw the front elevation first. No, let me draw the plan first, then the front elevation. The plan, starting with a circle. No, let's draw the center lines first as engineering students. So line. Engineering procedure is to draw the center lines first before we draw any circle or a cylindrical object. So we should follow engineering procedures. Now, those are my central axis. I want to start from the plan. The top view, the plan of a cylinder is a circle, and our radius here is 40. Because of my drawing space, we'll be using radius 20. Fine. And the radius of the smaller, what's it called, the smaller intersecting cylinder is 30, radius 30. So to do that, I'm going to do it this way. Okay, so I'll be drawing the other smaller cylinder that intersects it at radius, which diameter is diameter 30. So we're drawing a line out. Come on. 30 divided by 2 will be 15. And up 30. So I simply draw to meet my line. Fine. Go again. Come on. Fine. So the lines I used as a mechanism to get to where I'm going, I can easily delete them now. And I won't need this protrusion, so I can trim that off. Okay. Now what is left for us to draw is the front elevation, which I'll be using line tool for. I need not measure the front elevation since I can transfer the measurement from the plan. If you ask why am I able to do that, is because I'm using object snap. So the height is 75, and of course 40. The diameter is 40. Said earlier on. Okay. Now we're told that the cylinder, the 30 diameter cylinder, intersect it at 30 degrees. So first draw a line intersecting the central axis at 30 degrees. As you can see, my mouse isn't going in a 30 degrees increment, so you can easily use. I will put off my auto mode. Since I need 30 degrees, I can track it by putting on my polar mode. So I'll set my polar to go to track 30, 60, 90. 30 is all we need. Okay, you see we're on 30 now. I just want to draw the center line to be a little long. Okay, we're fine. Now all I need to do next is to offset this line up and down so as to get my 30 pipe. So offset 15. Okay, then finishing it off so that I can trim it all at once. I'm trimming off. Don't trim it. Okay, it is making sense. So I made the mistake trimming off this, so I'm going to extend it. Undo. Okay, I easily extend this. And remember, this front elevation should be in outlines, so I'll be changing it here to outlines so that it can be an outline layer. Okay, I'm constantly saving my document. So now what we to do next is to draw a semicircle or a full circle here, and draw a semicircle or full circle here, so that we now intersect the line. We transfer the lines from here all the way up and from here all the way down. Now I'll be drawing a circle. As you all know, half circle is an arc. So let me use start, end, center. I want to start from the center point. Let me start here, center. AutoCAD draws anti-clockwise. That's why I'm drawing my drawing this way. Fine. Go again for this. Oh, come on. Exit. Arc. I want to start from the center. Center. And no, it should not be. It should not be 17. It should be 16. Okay, let's make it parallel this way. Let's make it perpendicular. Okay, let's draw a line such that it is perpendicular to the line we have drawn. Okay, fine. Are we on? Yeah, fine. Oh no. Okay, fine. The line is drawn, so I want to trim off the trimmables so that I can continue. Okay, and I'm taking this back to construction to outlines. Come on. Okay, so remember we are drawing a semicircle. A semicircle is simply a half circle or a curve rotated 180 degrees. No, it should be 15. Good. Now our next job is to divide each of these circles into 6 different parts. How do we do that? Remember from our technical drawing days, we can take a compass and strike an arc. You can take a compass and strike an arc. You can see my curve is not perfectly drawn. So I want to come on. I will just extend it. Okay. So I will strike an arc. We already know our arc, the radius of this is 15. So let's do a little thing. Center, anti-clockwise. The radius will be 15. 1, 5. Isn't that wonderful? You see? Let's strike another. No. Center. I know the radius is 15. 1, 5. So I'm drawing the other way. Okay, let me just go again. Remember, my AutoCAD draws anti-clockwise 15. That's why I encountered such problem. Okay. Okay. So still drawing my arc and center, and anti-clockwise is this way, 15. Perfecta. Now this arc is obviously too long. How do I go about it? I can take a circle or anything and just trim off what I don't need. In this case I want to use a circle. Undo. Why I'm having such a problem is because my drawing is small and it's not really zoomed out. Okay, fine. So I will highly suggest to you, when you're drawing, be it small objects, be it big objects, have a reasonable zoom so that you won't be making some unnecessary mistakes. We can as well trim all these circles, all these arcs. Let's just trim it once and for all so that they look nice and presentable. Okay. So now all the arcs, no, that's not a good circle. Remember, the two circles I just drew, they are just reference for me to have something to trim them off. They aren't anyway part of the drawing. If you don't do it, will your drawing be accurate? Of course. Or will it be as neat as mine? No, not really. So next thing I want to do is to project a line parallel to this axis from each of these divisions, which is what I will do. Remember, we're already using polar mode. See, remember to zoom in to verify the accuracy of your work. Okay, fine. Line again, fine, locked in. Okay, I want to make sure I get the green dotted line, which I've gotten, fine. Then go again. I want to be sure I got the green dotted line. be sure I'm on okay. And I repeat for the last two. Oh, come on. Fine. Then the next thing is I want to repeat the same division here, which you already know how to do. So I'm going to fast forward. Yes, I'm done with the measurement with the arcs here. So I'm going to use the same process to extend a parallel line to the axis here too. But this time around I'm using straight lines since the axis of my cylinder here is straight. So I'm going to make sure it touches. Fine. So I'm going to repeat for the remaining divisions too. Now I'm done with all the lines. The next thing I want to do is to give it some labelings. 0 to 6, 0 to 6, or better still 0 to 12, so that I will know which line cuts which line. Fine. Before we do the labeling, we need to project all these lines from the plan to the front elevation. So I'll go for line. At every point each line meets the circumference, I will be taking it up. Okay, line again. Now if your drawing is well made, you notice this and okay, go up. Okay, so if your drawing is well made, you will discover that this line and this line will meet the circumference on the same vertical line. So if I plot it up this way, do you get what I'm saying? We should be careful of one thing, which is unnecessary errors. One of the advantages AutoCAD and using CAD to draw has brought for us is minimizing our errors and bringing much accuracy to our work. So if we are still drawing, but because of not knowing how to use objects now properly, or not understanding the application, we are still introducing some errors. Of course, it won't work. Not because the method doesn't work, but because the draftsman, the designer, introduced errors in his measurements by himself. Okay. Now, the curve we are looking for goes something like this, from here to here. So how do you go about it? To draw any curve, first let me take a zoom at it. That's my area. Okay. So first thing is to know that every job that you're going to do on AutoCAD has its own right tool. You can't use a line tool to draw a curve. You get nonsense. You can't use a arc tool to draw a line. No, you have to use the right tool for each job. How do you know which is the right tool? I want to draw a curve. Any curve, be it any loci, any locus, any parabola, and the likes of it, use a spline tool. So I'm going to go ahead and invoke the spline tool. Spline. So first, to use the spline tool, I have to invoke it. Then I'll pick the points. Point 1, point 2, point 3, point 4. Immediately I'm picking the point, you will observe that AutoCAD is automatically bending my line to suit my curve. I want to pan up. Come on. And once I'm done, I'll keep it on that line and enter, and that's all. Then this line, I'm going to put it on my outline layer. This is the curve of intersection I'm looking for. Now, it is quite very important as draftsmen and as designers to make our drawings have a neat outlook. So it's important to trim off some unnecessaries like this. Okay. You can as well trim this off, but I need a reference to trim it off. Okay, trimming is done. So all that is left for me to do now is, one, I want to put a title to it. Two, I will need to put my labelings to it. Then I'll need to add some dimension. To put a title to it first, I'll use DT, and the title is curve of DT, starting point, angle of rotation 0. Curve, I want it in capital letter. Curve of intersection of two cylinders. Now I want my text to be on the outline layers. Now the next thing I want to do is I want to add some dimensions to it, so I'll invoke DIM. First, I would like to know the dimension of this. It's 40. Okay. Then height of my cylinder, 45. Then the diameter of this, 30. And voila. The only thing left is the numbering, which I will do right now. Exit. Let me start my numbering from this. So I'll use DT. 0, 1, 2, 3, 4, 5, 6. I'll go down. I know this is so 0. Same way, 2, 1, 2, 3, 4, 5, 6. If you know the principle with which this works, the numbering, you may do the numbering first, you may do the numbering last. But going by the way of the technical draftsman, they will tell you 3 must intersect 3. Let's see if our 3 intersect 3. Okay. They tell you 3 must intersect 3. 0 must intersect 0. This is 0. Is 0 intersecting 0? No. 0 is on one of these lines. Okay, then my numbering is wrong. Let me check my numbering and do that. Okay, if this is 6 and this is coming up here, then here will be my 6 and 0. 6, 0. Then here will be my 6 at the same time 0. Okay. Then if this is my 5 is on this line, 5 is on this line. 5,1, then it's going that way to 4,2, and here will be 3. Okay, here will be 6, here will be 7. Go that way. Our number system doesn't get to 7, so we can leave that out. And voila, thank you for watching this episode this far. Here is our cover vista session. Thank you for watching. Engineer Adebisi A.T. I've been your instructor, and for your project drawings and co, contact us at Computer Made Easy. Thank you.